Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Yeah, so we are trying to discuss about what is container. So here objective is this one. We want to save cost, time, and improving the quality of the software and in a data center while running the applications at a large scale. So when I ask what are the components we need to run for applications, one application, so we got to know we required 111 resources from the namespaces. It can be created multiple, but allowed by operating system 111. We also understand that role of C groups and capabilities. And we also understand the file systems. Okay. And different kind of file systems and all. Now we also understand that the architecture which we are running using right now is for the personal computing, not for the data centers. It was not architect designed for data center. And then we also understand the evolution of computing. And then finally, we discuss about the drawbacks of virtualization. So you tell me now what to do as an architect. Each one of you have to act like architect. If you be at architect position and you have all this knowledge and you have objective in place for the organization, what you would do? What you do? Tell me. Anyone?
Try to
Am I
make it
audible?
light. Yeah.
Yeah. But how?
I would remove the hypervisor heavyweight layer. Also,
Okay. So
OS
let's do one thing.
load.
Let's do one thing. Let's remove it. So this is the hardware layer. On the top of that, here you have a kernel. I'm not putting hardware. And top of that kernel, you know that, right? Create one mount, one network, one pit that will be shared by multiple user 1, 2, 3. Now each user will run application Apache. They are running Apache. So this guy is running Apache on 80 port. Will he will be other users will be able to add run the Apache on 80 port? Tell me.
No.
Why?
What is already in use?
The same network which is being used.
Same network, because remember all users are using the same network. You see the 3 users sharing the same network. So he cannot use 80 port. He also cannot use 80 port. Now this Apache first one, Apache is running on 50 PID. Second Apache will be able to run 50 PID?
Not possible.
No,
Possible. Why?
it's a unique PID for each process.
PID map has a unique process, right? So 50 PID is not possible. Wonderful. Now guys, first Apache is writing us files in C Apache. So if second Apache also will write a C Apache, this will be override. Data will integrity will be not managed, right? Data integrity, correct? So C Apache, can he write? No, not C Apache. So now you tell me, you are able to run 3 Apache, 3 users. So look at this here. Here the wastage where you want to run 3 Apache, you need a 4 operating system. Okay. 1, 2, 3, and 4. And plus one hypervisor you need it, which is heavyweight basically. Heavyweight means consume CPU, RAM, and storage licensing cost and operating system cost also. Here I am having only one. Here I am running 3 applications, only one operating system. But is it useful for us for the data center? What is the problem you will face in the data center at the mass level?
Multiple configurations you will have to maintain for one application.
Yeah. And load balancer will work.
Resources.
Remember the data center, you cannot run application at the large scale if you don't make it work for the load balancer. Remember the load balancer, use of load balancer. So tell me, load balancer will work or not? Let's say you change the IP port number. Application will run, right? Will it run 3 applications?
Yes, it'll run.
But will you be able to use it?
No.
See, human hit the domain hit to the load balancer, external load balancer, and load balancer will balance these 3 Apache. Will load balancer be able to load balance all these 3 Apache? Tell me.
No.
Why?
We can do a configuration for the balancing, right? Load balancing configuration
But
for the different
how?
ports.
What is the rule of the load balancer?
So basically, you can configure the load balancer with the different endpoints, right? With a different configuration, and then either one of the round robin other way we can actually balance it, right?
But you said different what you said, different?
We can have a configuration with the different ports, right? Where like
Different ports. How? One load balancer, have you seen? There are 2 kind of load balancer. One is a node network load balancer. One is an application load balancer. Any load balancer, have you seen having load balancing at the different port?
no.
Say here, this is the load balancer. This is the one machine, or it can be VM also. Okay. So now this is running on 80 port, 81 port, 82 port. These 3 can be a different user, different machines, or different VM. So will this load balancer will balance all these 3 instances?
It's already dedicated.
Load balancer required the unique port. Remember,
Correct.
load balancer required unique port and different IP address. Mind it, different IP address. So guys, yes, your idea was very good. Someone suggested the idea, get rid of multiple operating system and hypervisor. That was a great idea. But this is not helping us to create a streamlined process for avoiding multiple configuration and make it available for the load balancer. So what we do? You tell me. what we do? Tell me. What we do? Any idea?
We have to get rid of the personal computing architecture in some way.
So guys, is there any possibility? Think simple. See here, look at this. How many user you can create? Multiple. Operating system, multiple. How many root file system you can create? Multiple. PID, multiple. Network, multiple. So here, is there any possibility? Think simple. I will create a
Can we
user.
create multiple profiles or
Okay.
something?
Think, yeah, I'm going in the same way. Can we create a user? This user is created by whom, you know, that user namespace which is in the namespace and kernel. All this thing. Can we create user? Can we initialize one mount root file system? MNT root file system. See that here. Is it possible? See here. There is only one root file system at the system level. But can we do one thing? For this user, I will give separate root file system. Is it possible? Yes. That means this user will not be using this root file system. This one will have a separate one. Possible? Yes. Can we do one thing? This user will give their own PID. See here. Own PID. Is it possible? Yes. This user, I will give their own network. Is it possible? Yes. So let me create one more user, guys. There's one more user. Mount mount network PID. All this is powered by kernel. Is it possible? Tell me. Is it possible? All of you? Guys, are you there?
So shouldn't there be multiple OS, or with one OS it's possible?
No. Remember, where is the multiple OS? I repeat, kernel is only one. See, what you have? Root file system, network, PID. Root file system, PID network. This kernel itself is allowing me, is it possible?
Yes,
There's
it
no
is
multiple
possible.
operating system. Possible.
Yeah, possible.
If OS allows, then
No, it's allowed. No? You see here. No, OS is not allowing. That's a different thing. But it can. Correct. It's a program. It can. Correct, na? Kernel can allow. Operating system is not allowing. Kernel can allow. So guys, now you tell me. Think simple. These applications can also run on the 80 port 50 PID C Apache. This application can also run on 80 port 50 PID C Apache. See that here, how beautifully it can be possible. Why it is not possible for these three users? Why it is possible for this user? Because what has happened, kernel assigned these three users common PID, common network, common root file system. But when it comes for this user, they have allocated separate one. Each user, one PID, one root file system, one network. This is a way. Can we not avoid the multiple operating system? Tell me. And heavyweight hypervisor? Tell me. A cost of running operating system, CPU, RAM, storage, and licensing cost, and heavyweight hypervisor. Can we not save? Think about it. Can we save it? So now guys, whatever the resources you saved it, you can run more user like this, more user like this. Because here you have only one kernel. Remember, only one kernel. And you are initializing nothing but a multiple network, multiple PID, multiple root file system. But this time not shared one. Each user will get their own allocations of it. So tell me, don't you think so you'll be able to save so much of CPU, RAM, storage, licensing cost, and how much time it takes to create a user, guys? How much time it takes to create a user?
Few seconds. That's
Yeah, you know that. So tell me, is it good idea?
one question I have, Rajesh. So when we talk about can be and can have, right? So we talked about, right, allowed by and can be, right? So I want to know, it means that are we kind of manipulating or kind of modifying the operating system or the design to make it to the next level multiple
No, no, no. We are
thing,
not.
and it's
We are not
already
modifying
capability
operating.
available? Yeah.
We are not modifying. You know what? Tell me. Forget about this. What operating system allowed or not? Is it possible or not? Because here, if they can initialize multiple user, what? Why they cannot initialize this namespace? This namespace is nothing but a code itself. You can initialize multiple times. Correct, no? Theoretically,
It
it's
should be
possible,
possible
right?
logically. Yeah. Yeah.
Yeah, yeah. So now the guys, but you know what has happened? Operating system said no, no. See here, I said no. We will not allow you to create multiple root file system for each user. I mean, one root file system for each user. I will not allow you to create one PID table for each user. I will not allow you to create one network for each user. I will allow you to create a shared one. Why? PC. They said, operating system companies like Microsoft and Linux said, listen, I developed operating system for PC people. I mean, for the human beings, not for running data center. You are using data center, you are using this architecture in data center, that's okay. But our primary objective is to run for human being, for the PC. Then this guy came and said, okay, his name is, uh, what is this? I forgot name. Father. I immediately forgot his name. Solomon Hikes. Yeah. So this guy came and said, no problem. He's the one. I'll show you his name. This guy came and said, no problem. Solomon Hikes. See, I understand your problem. You will not allow a user to allocate the individual resources like MNT, PID, and network. I understand your limitation. So can we do one thing? Let's not disturb the operating system. Let's do one thing. I will write a wrapper on top of it. Think about it. Very simple solution. Here at some places, he write a wrapper, some software. Now this software directly talk to the kernel? Yes. And they instruct kernel, please create user and create one network, create one PID, create one root file system, and attach all this root file system, PID, and network to this user, this for this user. So every user will have their own resources. Who's managing it? This software. Now you are not being disturbed, and this guy directly talk to the kernel. So you need to allow this software to talk to the kernel. That's all. So if I talk to the kernel, I will manage, means this guy will manage all this particular user. So now tell me one thing here, what is Docker and what is container? Tell me. Last question. What is Docker? What is container? All
Docker
of
is
you?
the software and container is the users.
Yeah. So guys, this is your Docker and this is your container. See, all these are container. Okay. And Docker is lightweight compared to hypervisor. See how beautifully they played. So in short, what you are saving here. So look at this. In this, you want to run 3 applications. We need a 4 operating system plus hypervisor heavyweight. Here you want to run 3 applications, only 1 operating system, and you are user actually. Container are user. Understood, right? All of you? How many of you have understand? Can you please put it in the chat? Chat window.
Rajesh, when you said containers are users, so how do you
Hello.
Hello.
Your voice is not coming. Someone is speaking, I guess.
I'm asking, when you're saying that containers are like users, how are you relating these two things, users and containers?
You are also container. I am also container. We are all containers only. But the difference between the container of Docker and me is only one, is the me, Rajesh Kumar, I logged in. I am able to access PID, network, and root file system, which is shared with all the user. The user which is created by Docker, whatever the network, PID, and root file system they get, it is not shared. That's all. We are unfortunate containers. The container which is created by Docker is fortunate because they have own resources. That's all. That's the difference we have. Are you getting my points? What I'm trying to say?
Yeah. Okay. Okay.
Remember, you are also a container, but shared resources. We are sharing. Let's say you all log into my laptop. We'll be sharing same C drive. We'll be sharing same PID table. We'll be sharing same um, um, network. But these guys are not sharing. But who's doing it? Ultimately coming from the kernel with the help of Docker. So guys, this is the Docker and all these are containers. So many people say container is having operating systems and all. Don't make mistakes. So that's the reason here I said, what is Docker? So Docker is a container management tool. Now what is a container? So there's a two definition. One definition, which I'm going to tell you, which is very popular. A lightweight. Lightweight means when I say consume less CPU, less RAM, less storage, no licensing cost, lightweight, fully independent application runtime environment. Yeah, it's environment. Fully independent means, see here, you don't need to go anywhere else for anything else. You within yourself, you are everything. You get their own mount, own network, own PID. Everything is you have it. Don't need to share the resources with other user. You are fortunate one. But if I say in a technical way, container is a allocations locations of one network, one uh, PID table, one root file system, two, you each user, and for what? For running applications independently and cheaper way, cheaper and faster. That's all. So guys, did you understand now what is Docker, what is container? I think I took a little bit more time, but with this in understanding, rest of the sessions will be very easy for you.
So one curious question I have, I may ask.
Yeah, please.
So this is understood. So how come the hypervisor was so heavy-weighted and the wrapper Docker concept came was light-weighted, which Solomon saw, but the other guy couldn't see, or it was because it was still data center focused, right? When the VMs also arrived with the hypervisor. So what was the differentiating factor? What flag got reduced?
This is a, I would say, evolution. Maybe I don't know what was the why that at that time it was not thought, but it's a part of the evolutions. And maybe the operating system still they wanted to sell out more operating system, so they don't wanted to get rid of it. Maybe because of reason, I'm just guessing it, because you know, major companies like Linux, different variants are there, and Windows make money from this itself, right? So maybe that kernel was not allowed. See, people will develop the technology when then kernel will allow to do that. Let's say here initially what happened in this case, Linux kernel allowed Docker to access the resources and recreate those resources as discussed, but the Windows were not allowing actually. Microsoft recently they allowed actually this. They saw that container technology is on the Linux is rapidly growing like anything. So they recently allowed and they started supporting from the 2019 onwards. So it's a part of evolutions uh, and stuff like that. Uh, don't have a complete knowledge on it, but yeah, just the guessing, some of the guessings. It's just all about the market, right? Got it?
Yeah, thank you.
Yeah, more questions, guys?
Hi Rajesh, I have one question. Hello.
Yeah, please go ahead.
So the concept of container is nothing but the runtime environment, right? So I just want to like correlate with the concept of the DIND Docker inside a Docker. So case, how this the flow will be there. Like you said, every container will be sharing a kernel, and with that respective environment they'll be running. But inside a Docker, in that way, right? Is that a user will be like the container which you showed in the green? It will be inside one more container. How it will be working?
uh to be honest, I've never heard about the Docker inside a Docker.
To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
Maybe some keyword terminologies which is you might have heard about it, and I don't know, I have never heard about it. I'm using containers from
Okay.
last 6 years. Remember here, it's very simple concept. Docker needs to talk to kernel to create a container. Okay, so kernel is at only, you can find it at only two places. Remember, Docker is not hosting any kernel. Kernel can be found out in VMs or in physical machine. So that means Docker is not holding any kernels. Docker itself is one application. How can it hold a kernel? Remember, Docker, if you see that the placement of Docker is just like an application which is running on the system, but it has a capability to talk to kernel.
Okay.
Got it?
Hey, Rajesh, Sriram here. Quick question. So,
Yeah.
can you hear me?
Yes, please tell me.
So let's say in this diagram you have like 1, 2, 3, 4, 5 users, and all those 5 users or applications are using Apache, for instance. Like how many Apache instance the kernel will maintain? Is it one or many?
All of which, five Apache, and 5
You
Apache will be running on the 80 port.
oh okay.
5 Apache will be having PID 50. All 5 Apache will be writing the location C Apache. Why?
So then
Because
yeah, I understand, right? Then how it is lightweight? Because what I understand reading Docker is like it's a layered file system approach, right? When you build a container within a Docker, right? It
okay.
should be maintaining one instance of Apache if all are using, let's say, Apache 7, for example, right? We'll if it's going to instantiate.
Sorry to interrupt you. Actually, that
Yeah,
is a different topic. The one which you are merging here, the topic is all about the image. So I'm not
right.
talking about that one. I'm not. That's a
Okay.
different topic altogether. I am talking
Okay.
about a container runtime environment. What is a container? So container is having 4 resources. Simple.
Right.
4 resources.
Right.
Only container runtime is having 4 resources: user, root file system, PID, network.
Okay.
Who's managing it? Docker.
Right.
That is what I was talking. So right now, when you get into we will get into that images development and all. We'll get into that. Then I'll talk about. This is nothing but a root file system. If I have to deep dive into a little bit more, so you'll
Okay.
understand what exactly layers and all.
All right. Okay. Yeah.
Yeah. Someone else was asking one questions. Okay, so you have asked like how it is saving a cost. Remember, if you have a 5 operating system for 5 applications, operating system itself consumes so much of CPU. Operating system itself consumes so much of RAM. Let's say I'll put it in this way. You create a 4 VM and you put the Windows in it. So forget about the application. Windows itself consuming so much of VM, I mean CPU, RAM, storage, licensing cost. Forget about the applications. But here in this case, you have no operating system, only one at the base level. So that way you save cost. Same time, to manage the multiple VMs, you need a heavyweight hypervisor. Here, the Docker, which is managing all this container, is not heavyweight, it's a very lightweight, consuming very small CPU, small RAM, and small storage, and no licensing cost because Docker is free. Make sense? All of you?
So one question so I have, Suresh, with respect to when we are thinking that the Docker is like a wrapper kind of thing, right? So it means that the kernel is it exposing certain APIs to the wrapper so that it can manage the users kind of thing at this point? Are we thinking that
No,
way?
that's all. They initialize n number of users. See, I can do manually also. Let me tell you here, you can create network manually also. If you're a root user, there are certain kernel commands are there. You can create as many network you want. as many PD tables you wanted, as many root file system you wanted, as many users which is allowed by default. If you know the network kernel programming, you can create. What they are doing in an easy way, they create user and attach 1111 of copy of this user label. So this user is not having shared resources, have their individual resources. That's all. Nothing else they are doing. See here, can. How many user you can
Yeah.
create?
So they are just leveraging the option of can to, make it a
Correct.
Dockerized one, right?
Yes. Yes.
Got
Yes.
it.
And which is not allowed by operating system because they say, boss, I am from PC concept, not for your running data center applications. More questions, guys? So in short, guys, you just need a lightweight kernel, which is of maybe somewhere close to 60 MB, not 4 GB operating system. Mind it here. I'm just talking about in a different way. You just need a 50 to 60 MB of kernel to run a container. Just imagine how much of storage, how much of CPU, how much of RAM you are saving it, and on top of it, no operating system Linux this cost, and top of that, all these containers, all this user, you can create it or destroy it within a matter of seconds. Imagine, just visualize this power of it. Make sense? So guys, that is the reason we say Docker is a container management tool. Guys, Docker has a two release. One is enterprise release, okay, and another one is community editions. The one which I am teaching you is community editions, okay. This is a free. By the way, this is also a free, but some addition software addition functionality which is coming along with the enterprise, which is paid. So I will put it in the paid category, okay. So this is the two version of it. Now you know this tool which is written in Golang. Yes. And then who's the father of this? By Solomon Hykes. By the way, July 2019, 19 or 20, I guess, he has left the Docker organization. So Solomon Hykes has written this one. Now, the latest release, if I see, we have a 20x, if I'm not wrong, maybe 21 also. Every week or every month we have a new releases actually. So we'll have to check it out. Apart from that, yes, if you are thinking this is the only technology which we have, Docker technology, other container management tools, we have so many, guys. So if you really want to know what is the other tools, so I'll go to the devopsschool.com, and here I will type container runtime. Okay, so many technology has come, so many technology has come, and many of these are popular also. So you can find out list of it during the lab session. You can review this stuff. Here you have Docker is one of them. Okay, so Docker is one of them. Okay, so this is the end of our discussion of what is Docker and what is container. Guys, can we move on to the next topic? Can we move on to the next topic?
Yes, Rajesh. Yes.
Okay. So guys, next question which I am having in my mind is, what is a Docker architecture? Okay, architecture, or some also we can call how Docker works. That is the things. So guys, what is happening here is very simple things is, in every architecture we are involved, right? We are involved. So we are human being and we talk to the Docker client. Okay, Docker client. Now Docker client talk to the Docker daemon. That's a server, we can call it. Okay, daemon. And you know, Docker server, Docker daemon talk to the container D. Now container D talk to the kernel. Yes. So Docker server have no direct access to kernel. They have access through container D. Okay. So we talk to the client. Client accept our commands, check whether the command is wrong or right. If it is wrong, revert back. If it is right command, send to the Docker server. And Docker server send that command to container D. And container D talk to the kernel and releases all the resources what I've been discussing since morning. Now question in my mind is how this Docker client send to the Docker daemon. So this is through REST API. Yeah. So if Docker client and Docker daemon talk to each other through REST API, then you know that this can be in a different machine. This can be in a different machine. Think simple. Okay, because they are talking through APIs. But today we will use only in the same machine. These things together, Docker client and Docker server or Docker daemon, we call it Docker engine. Together we call it Docker engine. So guys, so far I've been telling you Docker, 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 Docker. Actually, I'm not teaching you Docker. I'm teaching you Docker engine. Because when you say Docker, Docker is a company name. Docker is a company name, have a many product, including Docker client, Docker engine, Docker Swarm, Docker registry, Docker cloud, Docker enterprise, Docker DTT, and many things they have it. So Docker is a company name, of which Docker engine was the first of their product. Okay, so now the next question in your mind which should pop up, what is a container D? So guys, if you don't know the container D, just put it in the Google. Okay, and if I put it in the Google, then I found out container D is an industry standard container runtime. Yes, industry standard for what? Container runtime. So basically guys, if you are developing a container solutions like a Docker or the one which I have shown you, container runtime solution, we all use the container D. So container D is a one of the tool which is which has become a industry standard to talk to the kernel. So you may have a developed so many different technology, but ultimately this library is become a standard, market standard, industry standard for talking to the kernel. Simple. Okay, so this is the container D. It's a free, it's open source, and you can get it in the Linux. Windows you have to install it and stuff like that. Okay, so this is the architecture. And then kernel, you know by now, we have a two kernel in the whole planet, which we use it, which we know, which I know right now. One of these is Linux kernel. And remember, Linux kernel empower many flavor of operating system like a Debian, SUSE, Ubuntu, CentOS, Fedora, RHEL, Kali, this, that, HP, many flavor of Linux operating system is powered by kernel. Linux kernel. Windows kernel is a completely different kernel that empowers all the Windows version of operating system. So guys, this is how the Docker architecture or Docker works. We send the command to Docker client through REST API is sent to the server sent to the container D ask kernel to release the resources or destroy the resources, initialize the resources or destroy the resources. Guys, did you understand that, the architecture?
Yes, Rajesh. Rajesh, one question. So when we were talking about the Docker software, right, the software which manages the containers in the diagram which we are showing, we are talking about a Docker engine, right?
I was talking about the Docker engine, but people when they usually they call Docker engine as a Docker. It's like become a part of the life. So
Correct.
whenever you say Docker, basically you are talking about the Docker engine. That's all.
Correct. So that doesn't include container D, right? That runtime is a separate thing.
Nowadays in installer you get the container D, but it's a separate software. How you install it is up to you. You can install Docker engine alone, and container D, most of the Linux operating system, it comes by default nowadays.
Okay.
Okay, so now guys, after learning all of it, I want to learn Docker components. Okay, this is the most important sessions for me and for all of us. What are the Docker components? So guys, first thing, when I say Docker components means, okay, fine, I got to know what is Docker, I got to know what is container, but how can I get started? What I need to get started? I want the container, I want a container. So what do you need? Prerequisite. So first prerequisite, you need it Docker engine. And I think you know by now what is a Docker engine. So you need to install Docker engine in a physical server or virtual server. And then that's all done. Install it, start it. That's all. And use it. Okay. So you will install the Docker engine. How to install the Docker engine? I will show you the demo during the demo time. Let me complete the discussions first. Next one is, guys, next component which we need it is Docker image. Now I am having a question in my mind. What is image? What is image? So guys, I'm very much confident, like you have worked with VM's image. So tell me guys, let me define you VM's image. First VM's image, then I'll define the Docker image. So tell me guys, in the VM's image, what you have? Tell me. I hope you remember this discussion.
The VM images have operating system
OS.
within it.
OS.
So no. In OS, we should not tell. Why? Because the
Yeah, within
moment
OS.
it is just a files, right? Image contains not runtime environment. It contains files. Image. I'm talking the image, sir. Forget about that runtime. Image. VM's
Is
image.
files and
Ah. So what kind of files you have? Boot file system.
Boot file system, root file system.
It's a kernel. Plus, on top of that, they give you one root file system. Okay, that's in, and then on top of that, they have some users and applications also. In operating system by default, let's say calculator, it's already installed, right? I don't have to install. So many software which comes along with it. So few users also comes along with it. everything is there in the VM's image. Okay, so VM's one thing which you have: boot, root, user, apps, everything. Sometime what you will do, hey, Rajesh, do one thing: create one image which will have a CentOS operating system, then install the Java, and then top up the Tomcat, and then install the app, and create one image, and then the moment we run the image, we get the software. Don't you do that like this, guys?
Correct.
So now the question was not a VM's image. Question was, what is a Docker image? So guys, Docker image, yes. Look at the image. Docker image contains what? Docker image contains root file system. Yes. Docker image has no boot file system. That is the reason we have container is not operating system. Boot file system means kernel. So Docker image, any Docker image, you will have a root file system, user file system, application file system. Okay. So now you must be wondering, okay, fine, I understood what it contains, but what is the use of Docker image? One copy of Docker image, I said one copy of Docker image get mounted to each user. This is a major statement which I'm making here. I repeat, I said one copy of Docker image get mounted to each user and Akka container. Look at this here. I've been telling you each container will have one mount. Each user will have their own mount. So when I say mount or root file system, basically I am saying image only. So what happens when you create a container, they copy the image file and mount it to the each user a container. That is the one of the reason you go inside a container, every users will see their own C drive, their own D drive. Are you getting my points, guys? All of you? So literally here, understand guys, here it can be Ubuntu, here it can be RHEL, here it can be CentOS, here it can be Fedora. These are the root file system based on the kernel here. Okay, so think about it. Now you are getting the what is the image? From one image, you can create multiple container, multiple mount. I said copy of image. So guys, what is the image in a nutshell, in a simple way? Did you understand that? All of you?
I'm not pretty clear with first point. This one copy of Docker image get mounted to each user Akka container.
See, I've been telling you one statement, right? Each user get one mount, remember?
Yes.
Read this statement. Here,
Yeah.
this comes from image. See, mount.
Okay.
Got it?
Yeah, but you means right now you means showed right means you can launch container with file means root file system as Fedora or CentOS. So how can we launch different means file system with this one image?
This is a wonderful question. and the solutions you only have it. You know one thing, I've been repeating this statement all the time. There is only two kernel in the whole planet which we use it. One is a Linux kernel, one is a Windows kernel. Remember,
Okay.
when
Yeah,
you
yeah,
say CentOS, remember, it's a very simple terminology. When you say CentOS, then actually you are not talking about CentOS kernel. You say CentOS flavor of Linux, one of the flavor of Linux. So what is happening here is CentOS is also developed with the Linux kernel.
yeah, yeah,
RHEL is also developed using a Linux kernel. Ubuntu is also developed in Linux kernel. All 40 different variant of flavors. You should not say CentOS operating system. We call it operating system because it got used to it. But actually it's a flavor of Linux. So what is happening is in the CentOS guys also, they copy the kernel of Linux and top of that they write their own root file system and some additional utilities. So that is the reason I said here what is happening. If you have a 5 images, remember, if you have a
yeah,
5 image Docker images, so from one images kernel you have it here, Linux kernel. But here it can be Ubuntu, it can be Fedora, it can be Debian, it can be SUSE, it can be Line, anything. Makes sense? But it cannot
yeah,
be Windows, guys. It cannot be Windows. Mind it here.
yeah, yeah,
Got it?
yeah. Thank you.
So yeah. So here from one image you can create a multiple content. So this is the image. Again, I repeat, image contains root file system. Now you want to see, you want to tell me what is a root file system? Then I'll tell you CentOS is a root file system. Ubuntu is a root file system. Debian is a root file system. Fedora is a root file system. SUSE is a root file system. Any flavor of Linux, technically it's a root file system based on Linux kernel. But in short, what we call it? CentOS operating system. Are you understanding the terminologies how is being played out? Guys?
Yeah, yeah,
Yeah. So this is important. This is Linux kernel, or it can be Windows kernel also. Okay, that's all. A root file system means what? Ubuntu, CentOS, Win 2019 or something. User means root, or here in Windows we use administrator, right? An application, you understand. Okay. So guys, this is the second component of Docker. So guys, if you want container, what do you need? If you want container, what do you need? You need
Docker
image.
image.
Yeah, Docker image. Now guys, let me tell you, tomorrow I will teach you more detailed way, deep dive into the Docker image. And someone has asked, someone has added up points, right? Layers and all stuff like that. So tomorrow morning I'll talk about it. Right now I'm talking my topics right now as per the agenda. Okay. Third thing, guys,
So
I
one,
need a doc. Yeah.
sorry, so one more difference compared to the VM is the you talked about the flavors of the OS, right? In this case, with Docker image, you can it has root access, so you can use Debian, Ubuntu, and
Yeah.
unlike
File.
VM where you are fixated with one OS, you cannot
Yeah. You
deliver
cannot
to
change.
that way, right?
Yeah. If you want to change the operating system, you have to change the VM image itself.
Itself.
Yeah.
Yeah. Okay.
Okay, guys. Third component is that the question is in my mind, okay, fine, Docker image is important, which may contain, see, root file.
To watch our complete session, enroll for our premium membership. Click onto the join button and enroll yourself with the best suited option.
System or applications along with it. It can be. So the question is Docker image. Some of the examples I'll give you image. Ubuntu, CentOS, and here Jenkins. So when I say this is the image, so you know what? This contain root file system plus user file system plus app. That's all. But this is also contain root file system. But you know Jenkins contain Java plus Jenkins. All this together. So when I say Jenkins image, it contains all of which. When I get CentOS image, I get only this. Okay, understand this way. Okay guys, third important question is from where to get an image. I don't want to create it because I don't want to create now. I will create later. It's like this. First, we need to learn how to ride bicycle. Once we learn how to ride a bicycle, then after that we can learn how to do the manufacturing or assembly and stuff like that. So we are learning how to write a container, how to work with a container, not immediately jumping on how to develop an image. So guys, do we have any places where we get the free image? The concept of getting at an image at certain location, we call it registry. Yeah, we call it registry. So now a question is, what is registry, which is the third component? So guys, registry basically contains repository. Yeah, repository. So in that case, tell me, GitHub is registry or repository? Tell me. GitHub, you might have used it so many times. GitHub is a registry or no. Think one more time.
It's a registry.
Registry.
It's a registry.
It's a registry because at a GitHub you can create as many repository. Okay, so it's a registry. And guys, registry contains version of file system. Yes, I said version of file system. In your Git repository also, what it contains. Many people think using Git you are doing the file versioning wrong. Many people think in the Git you are doing the file versioning. Very much wrong. Git is not doing a versioning of file. Git is doing the versioning of file system. Mind it, there's a two different terminologies. File system. SVN doing the file versioning. CVS is doing file versioning, but not Git. So versioning of file system. So now you must be wondering why I'm talking about Git. I should be talking about the Docker. I am talking about Git because you know Git. So I want to correlate with the Docker. Why? Because the mother of Docker image and Git repository is the same, and that's called SHA algorithm. Git is powered by SHA-1 algorithm. Docker image is powered by SHA-256 algorithm. So anyways, we'll come to that later point of the time. But here, registry contain repository, repository contains version of file system. And here in the Docker image, when I say version of file system, that means root file system, user file system. These are the versions. Some of you said layers. These are the layers. I'll talk about a little bit later, not to confuse you now, but in short, the question was very simple. Where to get the image? What image? Ubuntu image or Jenkins image. Where to get it? Registry. There you get repository. Download the repository, you get the image. Image repository has what? File system. What file system? Root, user, apps. Simple. So now guys, which are the public registries are available? So guys, these are the public registry. We have hub.docker.com. Google registry is also public registry. Private registry you want to set up for your organization. When I say public means anyone can access. Private means only your organization can access. So you can use Artifactory or Nexus and all, Sonatype Nexus and all. So for this training, I am going to use hub.docker.com. Let me introduce you hub.docker.com. It's a registry. Mind it, it's a registry. So guys, here, this is the registry. I'm going to log out for it. So you'll see the home page. And you see here, this is the registry. How many images are there? I think you should read out. Look at this. Okay, so how many images you have? You decide. Some of the popular images you have Postgres, Traffic, Ubuntu, MariaDB, MySQL, BusyBox. You know. So what do you want? Search for it. Ubuntu. So when I say Ubuntu, don't think it's operating system. It's a flavor of root file system. Here Ubuntu. You want Jenkins? See guys, there's different filters are available. Verified publishers, official images, different categories of image, operating system, Linux, Windows, architectures. So all this thing you can see. So guys, did you understand that? All of you, what is a registry? Registry contain repository, repository contains your image in simple. Did you understand all of you? All of you?
Yeah.
Okay. Now guys, last final component of Docker is 4. Final component of Docker is Docker container itself. Yes, this is what you wanted. This is what you wanted. So now what I'm going to do, understand that. See that, very simple. What is a Docker container? You know that. But how to get it? So human will send that command to client. Client will send that command to server. Server will send that command to container D. You know that. Container D will send that command to kernel, and kernel will create, mind it here, create one network, create one PID, create one mount using Docker image. Remember, mount. See here I said, right? Docker image, one copy of Docker image get mounted to each user a container. So they will create one network, PID, and one mount, which is a Docker image, and create a user, one user, and this last statement, attach network PID and mount to the user. This is the things which is done by kernel, and the container is running. When you go inside this user container, you will see your own C drive, D drive. You will see starting with a 0, 1, 2, 3, 4, and you will see your own network. That is the whole environment. So in short, whatever you have in image, mind it, whatever you have in image, it can be Ubuntu or it can be Jenkins. You get inside a container running. That's all. Did you understand? That is the other perspective of the container definition? All of you?
Yes.
So simple, guys. Okay. So guys, these are the 4 components of Docker: Docker engine, Docker image, registry, and Docker container. You need to work with it all the time, all the time. Okay. Now, one more thing which we have is, what is a Docker workflow? This is the one more topic which we have. All these are theoretical. I'll show you the demo also. Just give me some more time. I'll finish and then move on to the Docker, demo. Docker workflow, container workflow. Okay, Docker workflow, container workflow, and how to install Docker. How to install Docker? That's the next question. Okay. So guys, what is Docker workflow? Let me tell you here, very simple. When I human send the command, same to the client, okay, when humans send the client command to the client check that command, think whether you gave the right command or wrong command. Client receive the good command, pass it to the server. Now you know what, server, before sending the command to the container D, check what, if image exists. Which image? This image, this image in a local registry. Okay, see here, if this image will not exist, think about it, how it can mount that all the file system to the container. It's not possible, right? So how to mount? So here it check if it exists in local. If yes, then it talk to the container D, and then container D talk to the kernel, and rest of the things happen. If no, let's say this image is not in local registry, then download it. Download from hub. It's a default one, hub.docker.com registry, and then finally call for the container D and kernel. So did you understand that what is that server is also one task which is doing to check the validity of the request? Guys?
Yeah.
Yeah.
Okay, great. So guys, now the container workflow, sorry, container not workflow, life cycle. Now coming back to the real topic. Almost all the theoretical part is over. Life cycle. Now guys, I have no understanding with container life cycle, but I know you know what is a VM's life cycle, because VM's technology we all are using from last 20 years. So tell me, what is the life cycle for the VMs? Remember, life cycle means what? Start to end something. Everything in this planet, on this planet, has a life cycle, right? Even planet itself has a life cycle, start to end. So tell me, what is a VM's life cycle? Tell me.
Creation of the image, then creating the VM out of that image.
So create image is created. Forget about the image. VMs. I'm talking the VMs. VM's image. So I create the VM. After that,
Create the VM,
start the VM.
start the VM.
Correct? If I have started, I have used it, I have to stop it. Can I stop it?
Yes.
Can I start it back? Remember, starting the VM, stopping the VM, you can do only if the VM is created. Okay, mind it here. These are the very basic flow. Some of you might find odd, but we have to understand this. You create a VM, start the VM, then again stop the VM, then again start the VM. Now I want to restart the VM. Can I do that? Stop and start? Yes. If the VM is running, then can you pause the VM? And can you unpause the VM? I'm sure you might have done it, all this stuff. Nothing new I'm covering. Create a VM, start the VM, stop the VM, start the VM again, restart the VM, pause the VM, unpause the VM. For pausing, that has to be running. For unpausing, that has to be paused. You know that. Okay, and kill the VM. And finally, you want to remove the VM. These are the things you've been doing with the VM's technologies from last 20 years. This is called a life cycle, correct? This is called life cycle. So guys, are you comfortable with it? Are you comfortable with this life cycle?
Yes.
Yeah.
Yes.
So I think if you're comfortable, then why we are not comfortable with the container? Yes. Create a VM using VM's image. Create a container using Docker image. Container is created, start it, and then stop it. Start it again, restart it, pause, unpause, kill, remove. Work is done. And what is a container? You know that very well by now. It takes second to create, second to, I'm not saying seconds. Mind it, I said second. Second to create, second to stop, second to start, second to restart, and all. So guys, this is your container life cycle. That means in a simple way, if I tell you, after installing the Docker image, even though if you don't download the image, server will do that for you. Whenever you create a container, you will have to do the same thing. How to use the container, that's a different thing I'll teach you. But how to work with a container and life cycle, these are the things you have to do. Now guys, next question which I'm having in my mind is how to install the Docker. So for that, I need a machines. So here, Docker installation instructions I'm sharing with you. You can use this instruction. So this is the instruction which you have, and how to install the Docker. So first we need to get one virtual machines. You can install in the physical machines also, but no one is using that anyway. So we need a one VM, CentOS VM, and this instructions, which is some of the prerequisite, you have it. Uninstallation is not required because we are installing it, not uninstalling it. There's a three method which we have it in this document. How to install Docker Community Edition via YAM, how to install Docker Community Edition via RPM package in CentOS, how to install Docker Community Edition via script. So any method which you use one in CentOS, will it work? Okay, so this is the Docker installations. I will follow the instructions in front of you. So that's the one thing. Now one last statement which I want to make it is Docker need root to send a command. Yes, remember human send the command to a client, right? So this human need to be as a root, or user needed to be a part of group called Docker. This is the prerequisite what we have, and you cannot ignore it. So either you become a root and run the Docker command, or add yourself in the group called Docker and then run that command. Anything is okay for you, and we'll have the same thing. So guys, more or less I have completed all the discussions part of it. Now I am going to show you the demo on how to install Docker and then how to work with the Docker. That means how to create, how to start, how to stop, how to restart, how to pause, how to unpause, kill, remove, and then followed by multiple more demos to be followed. So guys, any questions so far? Anyone have it?
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the 3D99 plan, and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.